Hello everyone, my name is Michael and I'm a software developer working at Paessler. Today I'm going to talk about the Paessler PRTG Data Hub, especially the state persistence feature. So the state persistence feature is a feature of the Data Hub that keeps the state of sending devices, and you can assign properties depending on the messages the devices send. What I'm going to explain you is also written down in the manual or in the examples if you want to have a template or another look at a written version of it. I do not explain the installation and the setup of the Data Hub and PRTG, so have a look at our other videos we have out there. Okay. So what do we have? We have the Data Hub running, a virtual PRTG version as I said, and what we also require is some device or multiple that send syslog messages, in my case to the Data Hub. SNMP traps are also fine. Yes, I have a test machine sending periodically data for that, just to make that clear. Again, I can recommend any IDE that has a JSON schema support, because writing the configuration file makes that so much easier. And we're going to start with the previous use case we already had, the forwarding use case, and we want to extend that a little bit. So maybe you remember we set up a simple syslog input, listening on any interface on the default syslog port 514, and forwarded that one to PRTG. And now I want to know which devices are actually sending the state or sending syslog messages to PRTG without filtering any messages. I just want to know, hey, which device is there. To do that, I have to deploy this rule to the Data Hub. I'm doing this again. And let's do it like this, and I copy it over to the Data Hub, the first one. So I copied over the syslog to PRTG file, and that should be this one. Let's do it first. Real check. Yes, this is the one with the syslog senders that tracks the state. I copy that one to the rule directory again. Sudo copy to etc Paessler data hub rules, and I will restart. Oh, don't have it in my history anymore. Let's do it by hand then. systemctl restart Paessler data hub service, just to make sure. We can also check if our new role is loaded. Should be. Yes, perfect. The one syslog to PRTG. Syslog to PRTG with tracking. Yes. Okay, so now that we deployed the rule on the Data Hub, I'm going to switch over to the endpoint of the Data Hub, authorize with the operational user, and just see what kind of devices are sending to the Data Hub. And with this little hack, I have an overview of all the sending devices that send any messages via syslog to the Data Hub. Okay, let's go to the next use case. Now we have now an overview of all the sending devices. What about if one device should send, for example, in an interval of 90 seconds or 60 seconds, let's say, a ping message to the Data Hub, and if it's not sending that, then it should go to an error state. We can do that with a Watchdog. The Watchdog basically says, okay, if this message comes in containing text, the heart emoji, because it should be alive, right? We said that this should be the OK state, and severity is OK with this. And for the dead state, this will be our default state set in the destination. It will switch to an error state. So let's see and deploy this rule and restart the Data Hub. We just copy it over again. Let's just copy everything over and redeploy the rule. Everything. Let's make sure. Yes. Sudo copy everything to etc. Paessler data hub rules and restart the data hub service. Let's see if the data hub service runs now. Did we get any message errors? No. Okay, so we deployed the rule to the data hub. I will authorize with the operational user. Secret, the secret password. Of course, let's have a look at all the entities that are sending. And you see we're getting this heart signal. And this is the device I want to monitor also with this IP address. So I can have a look at the specific endpoint for the entities and just get that one. Perfect. As you can see, it's sending the heartbeat, and if it's not sending the heartbeat anymore, it would be in an error state. So let's do that and replicate that behavior in PRTG. First of all, we're going back to the data hub group. Let's do it in the new UI. Why not? Go to the settings page, and first of all go to not the data hub credentials. We want the REST API credentials for this because we are not using a native data hub sensor. We use basic authentication with an operational user and the password we specified before. Save the settings. Perfect. So if you wonder where are the other sensors, I removed everything to keep it clean and tidy. I add a new sensor now. Instead of a data hub sensor, I use the REST custom v2 sensor, this one. And now for the URL, we're doing HTTPS to the data hub machine. On the endpoint API, I'm using the wrong slashes. Data hub API, this is always API v1, entities was it, and then the IP address. So for a JSON path, you can have a look at our knowledge base articles on how the JSON path is defined, but for this one we use the $sign properties. What is it called? Let's have a look again. Properties, Watchdog. Watchdog, and then state. We call the channel name is alive, and we will do a status lookup. If it is alive, or dead. That's it. I think the custom primary channel will automatically be set. Let's create the sensor. Oh, I didn't give it a good name. Maybe we should rename it to probably is then the IP address. Of course, if you want to go fancy with this, you should create own PRTG device or a group if you want to monitor more properties of this device. So let's see. We can check again if we have everything right. It's entities. This. Properties, so I had a typo. Properties, here we go. Properties, now do I scan again, please. Scan now. And as you can see, now the device is online. Perfect. So if this device ever stops sending the alive message, it will go to a down state and you get an alarm in PRTG. You can do this, of course, with all other protocols of messages and devices that are able to send to the data hub. So let's check the last example. We can do a complete state destination without the Watchdog example, without the fallback. For example, if devices send an on state and an off state, in this case I'm using a fan property, so the device should send me my fan is on or my fan is off in SNMP. This is just some arbitrary random trap UID I specify for my test system. You need to find your OIDs in the methods I mentioned above. There are usually vendor documentation where you can see the trap IDs, or even a search for them online, where you can find all the trap IDs and also the variable trap IDs that contain the text values. Okay, let's deploy this one to the data hub. I'm not allowed to copy that. Why not? Then I already have it prepared on the machine, so use that one because it does copy, keep the state, copy it to the Paessler rules folder where it will recognize it when I restart the service. Let's have a look at the status again, just to make sure. Yes, it loaded 2 rules. Perfect. Let's switch to our UI, just make sure that the rules are loaded. Use the operational user. Have a look at the rules. Just that it is loaded. Yes, it's tracking the state of keeping the state of SNMP devices. Perfect. Let's see if we already have some SNMP messages coming in. Yes, we have. So you can see here, this is basically a fake device I created that is sending SNMP messages, and you can see it's sending some values, and the payload is currently in just binary format. So we can now do the same also in PRTG and create a sensor that monitors that state. I add a new sensor. Again, this requires the REST custom v2 sensor. And my SNMP device. Oh, that's a little bit a lot. I just wanted the IP. The URL is again the one of the data hub. API v1. Entities and the IP address, and for this the JSON path, this time right, properties, it's called fan state. Let's make sure it should be fan capital, so let's do that. And the 2 values we get are on and off. So on status is okay, off status is bad. We create the device. Oh, we need a channel name. Fan is running. Create the device. And let's see in a second what's the current state of the devices. Perfect, it's green. So no channel list, we should see the fan is running and it's up and running. Perfect. So we now monitor our SNMP device in PRTG over the PRTG Data Hub. So you can get a lot more sophisticated with more devices, more sensors, more rules, more properties. You can define any property you like, knowing now the Watchdog example or even the on-off example. So yeah, that concludes our tutorial for this time. I hope you found this helpful. If so, feel free to leave us a like and consider subscribing. If there's a topic you want us to make a tutorial about, you can tell us in the comments. If you still have questions, also leave a comment or even better, a support ticket. Have a nice day and thanks for watching.